Today I want to discuss a very important topic. So that is K-map. So this K-map is very important in a digital electronics subject. In a digital electronic system, the simplification of the Boolean function is the very play an crucial role to reduce the order complexity size of the device and various type of techniques have been investigated. So apart from that, the K-map is a very popular algorithms to simplify the Boolean function. Now, in a K-map, so there is one is limitation is there. So this K-map is very applicable for the 2 variable, 3 variable, up to 4 variable. Now, the 5 variable, 6 variable, and 7 variable Boolean function. So it is not too easy to simplify the Boolean function using the K-map techniques. So that is why we can conclude that the K-map is more applicable up to the 4 variable Boolean function. Now I will discuss detail one by one. First of all, if I consider it, the 2 variable Boolean function. So 2 variable Boolean function means the input is suppose x and another input is y, and for example this output is there. So how many possible combination is there? So 2 variable possible combination is actually 2 to the power n. So here n is indicated as the number of variables. So in the particular cases, how many variables is there? 2 variable is there. So n is equal to 2. So that means 2 to the power 2. 2 to the power 2 means 4. So how many possible combination is there? So 4 possible combination is there. So first combination is suppose 0 0. Since this is the binary systems, there are 2 outputs, either 0 or 1. So first combination is 0 0. Second possible combination is 0 1, and next is 1 0 and 1 2. So this is the 4 possible combination for 2 variables Boolean function. Now, for example, for 0 0 combination, say output is 0, and for 0 1 combination, this output is 1, and 1 0 combination is for output is 0, and for 1 1 combination, this output is, for example, this is 0. So basically, this is actually the logical operation. So what is the meaning of that? Now when input is 0, both are 0, output is 0, 0 1, so that means x is equal to 0, y is equal to 1, output is 1, and 1 0 and 1 1, both are output is 0. So this is actually logical operation. So this logical operation can be represented as a function or in an expression. So that is called the Boolean function. So what is the Boolean function? So in that particular cases, the Boolean function is actually, if I consider only the 1, the Boolean function is actually output f is equal to x and y. So we can easily write it for that particular example. The function is x and y. Now, if I consider the 3 variable and 4 variable, it is not too easy. So what is the Boolean function? So that is why the K-map is very important. Okay. So basically, this portion is actually the logical expression, and this portion is actually the mathematical expression. So K-map is actually used to convert the logical expression to mathematical expression, that is the Boolean function. And this Boolean function is in a simplified form. So that is why the K-map is very important. So before discussing the detail about the K-map, so I will give some idea about some terms. So that is called the mean term. So 0 0 combination means, so mean term is 0, and 0 1 combination is mean term is 1, and 1 0 combination is mean term is 2, and 1 1 combination is actually mean term is 3. Okay. And what is the actual output? So actual output F is equal to M1 plus M2 plus actually M3 and M4. Actually output is M1 plus M2 plus M3 plus M4. Now in that particular case, we know that the M0 value is actually 0 0 combination, output is 0 0 1 combination, output 0. Only these values are M0. This is M0, M1, M2, and M3. Only this exists. So that is why in that particular case, so this equal to so M1. So M1 means what? X is equal to 0 and Y is equal to 1. So that is why X bar and Y. Sorry, so this value will be X bar and this will be Y. This will be Y. Okay. Now, so this is M0 position, M1 position, M2 position, and this is M0 position. So for two variable Boolean function, M0 is always for two variable M0 is always X bar Y bar. M1 is always X bar Y, and M2 is always X Y bar, and M2, and M3 is always X and Y for two variables. Okay. Next one is I'll discuss the two variable K-map. Two variable K-map means four possible combination. So there are four elements is there, 1, 2, 3, and 4, and one input is X, another input is Y. Since it is a binary number, so this X is either 0 or 1, and Y is either 0 or 1. Now, if I consider in previous one means this expression, only M1 value is 1 and rest of the M0, M2 and M3 value is 0. So that is why just we add directly. So this position is M0, this one is M1, this is M2, and this one is M3. And only the M1 value is 1 and rest of the value is 0. So just we put only the value of 1. And in the particular cases, only the one position is M1. So the output is actually output F. So this actually, so what is the value of X? So actually value of X, but here the value is 1. So that is why X complement. And what is the value of Y? Value of Y is 1. In this case 1. So X bar Y. Now, if I give an example, suppose two variable, so how it can represent in a Boolean function? So f of x comma y, so this equal to summation of mean term position. So we will consider only the one values. The one values is m1, so this is one position. Now, if I consider the another Boolean function for two variable x comma y, so this equal to mean term position summation of suppose 0 and 1. So what is the meaning of that? So basically the mean term position 0, this value is 1, and mean term position 1, so this value is 1. So what will be the actual expression for that particular cases? So we will find out using the K-map techniques. Okay. Now in that particular case, there are two 1 is there, so we can make a group using that 2 1. Now if I make a group, so what will happen? So we will consider only the unchanged variable. Now in that particular cases, in a group, if I consider this, so this one is 0 and this one is 1, so that means y is already changed from 0 to 1. We will not consider this changing variable. Only the unchanged variable is x. So what is the value of x? So in that case, value of x is equal to 0, and in that case 1, and this is also 1. So x is not changing. So only unchanged variable is x. And what is the expression? So expression is actually x bar. So why it is x bar? Because the value of x is equal to 0, and in that case, in a group, so that we have considered only the 1. So x at 0 position 1, and this is 1. So that is why this is x bar. Again, if I consider is like another example, suppose another example is x comma y, so this is the Boolean expression, and if I consider a, suppose m of 0 comma 1 comma 2. So what is the meaning of that? So this is a Boolean function, and the logical operation is in a 0 0 combination output is 1, 0 1 combination output is 1, and 1 0 combination is output is 1, and only the 1 1 combination output is 0. So that is why if I put this mean term 0 is equal to 0, 1 is equal to 1, and mean term 2 is equal to 1, so 2 is equal to 1, and only the mean term 3 percent is 0. So what is the K-map? What is the simplification of Boolean function? So this is one group and this is the another group. Now the group will be consist in a 2 to the power n form. So that means either the group will be 2, or group will be 4, or group will be 8. So this will be in a 2 to the power n form. And so when you make a group, so we will always try to make a big group, and we will also try to reduce the number of groups. So in that particular position, it is not possible to make this one, and this one using these three one. So we get a we prepared a group. So this is not possible because this is not the 2 to the power n. So in that particular case, how many groups will be there? So this is one group. Suppose this is the group 1, and this will be group 2. Now in a group 1, if I consider the group 1, so only the unchanged variable is x, and what is the value of x? X is equal to 0. So that is why this will be x bar. And now if I consider the group 2, so group 2, so what is the unchanged variable? Here x is changed from 0 to 1, but y is unchanged. So what is the unchanged variable? Unchanged variable is y. And what is the value of y? Y is equal to 0. So that is y. So this is. So these particular cases, f of x comma y. So this actually we can represent. So this in this way, and this actually expression is Boolean expression is x bar plus. Now, another possible combination is there. For example, suppose if I consider it, another possible combination. Suppose f of x comma y. So this is equal to suppose mean term of suppose 0 and 2. So what will be happen? So mean term and 0 and 2. So what will be happen? If I draw it, so there are 2 variable, 4 cell is there. So this is x and this one is y, this is 0 and this is 1, this is 0 and this is 1. And the mean term position 1, so this is 1, and mean term position, so this is mean term position 0, this is 1, this is 2, so this is 1. So what will happen? It will make a group, and rest of the value are 0. It will make a group, and this. So what is the output? This output is actually f is equal to. So this is the. Again, if I consider it, suppose so many combinations is there. Suppose Boolean function is actually the Boolean function is what? Another example is Boolean function is suppose 1 comma 3, 1 comma 3. Now if I consider the 1 comma 3, so what will be happen? This 1 comma 3 means again if I consider it, so this is x and this one is y, this is 0 and this is 1, this is 0 and this is 1, and 1 comma 3, 1 comma 3 means so this is 1 and this one is 3 and rest of the value are 0, and we'll make a group. And what is the output? This output f is equal to y. Why it is y? Because x already changed from 0 to 1, but y is unchanged. And what is the value of y? Y is equal to 1. So that is why output is equal to 1. And so this is the most simplified form of Boolean function. So that is why the K-map is more applicable for the 2 variable, 3 variable as well as 4 variable. Okay. Next, I want to discuss the another important parameter, so that is 3 variable. Now, before discussing the 3 variable, so I will discuss what is the mean time position of the 3 variable. So 3 variable means the 3 input is there. So input is x, for example, y, and input is z. And this one is output. Now, if I consider it the 3 variable, so we know that how many possible combinations there? 2 to the power 3, 2 to the power 3 means 8. And it will start from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. The 8 possible combination is there. And for that particular cases, so this position is actually the mean term 0, this will be mean term 1, this will be mean term 2, this will be mean term 3, and this is mean term 4, mean term 5, mean term 6, and mean term 7. Mean term 7. Look, now we have already discussed for the 2 variable cases. So we will consider only the output is 1. Suppose this is 0, this is 1, this is 0, this is 1, this is 0, this is 0, and this is also 0, and this is also 1. So this is the logical representation. Now this logical representation we can represent in a Boolean or in a Boolean function using the 3 variable K-map. Or it is possible? Okay. So before discussing this, so I will discuss what is the position of the. So this is suppose x, and this is y and z, and this combination is 0 0 combination, 0 1 combination, 1 0 combination, and this is 1 1 combination, and this is 0 and this is 1. Okay. And actually this is the mean term 0 position, this is m0, this one is m1, and this is m2, and this one is m3, this is m4, this is m5, and this one is m6, this one is m7. Okay. Now next we consider what is the output 1. What is the position? Next we consider the output for which possible combination this output is 1. Okay. Now look, in that particular cases, this is x, this one is y and z, this is 0 0, 0 1, 1 0, and 1 1, this is 0 and 1. And now what is the next we consider the output of 1. The mean term position 1 is output is 1. Mean term position 3. So this is 0, 1, 2, 3. This output is 1. And mean term position of 7. So this output is 1. So what will happen? Now we prepared a group. So this is the first group. And suppose this is the group 1. And this is another group. So this is the group 2. In a group 1, the y and z, so we consider the unchanged variable. So in that particular case, what is the y? Y is equal to 0 and this is 1. So that means y value already changed from 0 to 1. So we will not consider this changing variable or unchanged variable. And in that particular case, z is equal to, sorry. So this is 1 1. This is 1. Sorry. This is 1 1 and this is 1 0. Extinguisher. So only the unchanged variable is, in that particular case, only the unchanged variable is z. Z is 1 to 1 and the x is only the unchanged variable. So what is the Boolean function? What is the Boolean function? F is equal to unchanged variable is actually x bar z. Why x bar z? Because what is the value of x? Value of x is equal to 0 and in that particular case what is the value? Value is 1. So that is why x bar, and y z is actually unchanged is 1 to 1. So that is why this is z. So for that particular group. Now if I consider this group, what will be the unchanged variable? So x is already changed 0 to 1, 0 to, but unchanged variable is y and z, and both are values are 1. So that's why y and z. So this is the most simplification form of Boolean function. Now again we will give some another example of Boolean function. So what is the another example of Boolean function? Okay. Now for example the 3 variable Boolean function f of x, y, z, and this is the mean term position. Suppose 0, 1, 3 and 5. What is the meaning of that? So this is the 3 variable Boolean function, and in that particular 3 variable Boolean function, the output is 1 for the mean term position 0, mean term position 1, mean term position 3 and mean term position 5. Okay. Now we want to simplify this Boolean function using the K-map technique. And since this is the 3 variable, so how many possible combination is there? So possible combination is actually 8 possible combination is there. 8 possible combination is there. So this is x and this is y and z. And this is actually 0 0, 0 1 and 1 1 and 1 0. This is 0. Now one question will become, sir, why you have written here so 0 0 0 1 and 1 1 1 0? Because this is the algorithms. The algorithm always state that a consecutive cell, in a consecutive cell, only the one variable will change. So in that particular case is 0 and 0 0. This is 0 1. So 1 element will change. In that particular case 0 and 1 only and 1 1. So this is constant and this is only change. And this is also only one value will be changed. Now this is the mean term position 0. This is mean term position 1. This is mean term position 2. Mean term position 3. Mean 4. Mean 5. Mean 6 and mean 7. Now we will put only the values of 1. So here at mean term position 0 values is 1. Mean term position 1 this value is 1. Mean term position 2 value is 0. Mean term position 3 value is 1. Mean term position 4 is 0. Mean term position 5 is 1. And 6 is 0 and 7 is 0. Now there are 4 output are 1 and 4 output are 0. Now we will prepare a group, and group will be in a 2 to the power n form. And how it is possible? So this is the first group. So this is the group 1, and then we can prepare this is the second group, this is the group 2, and then we prepare this is group 3. It is not possible this make a big group. So there are 3 possible group is there. Now if I consider that in a group 1, so what is the output? Group 1 is this. So x is unchanged variable, and z is also unchanged variable. And what is the value of x in that particular cell? The value of x is 0. So that is why, so this will be x bar. And what is the another unchanged variable? Unchanged variable z. So that is x bar z. So group 1, so this is equal to x bar z. Next, if I consider the group 2, in a group 2, so this only the unchanged variable is x and another unchanged variable is y. And value of x is equal to 0 and value of y is unchanged variable is equal to 0. So that is why x bar. And next one is in a group 3. So what is the unchanged variable? Unchanged x is already changed from 0 to 1. What is the unchanged variable? Y and z. And what is the value of y? Y is equal to 0 and z is equal to 1. So that is why y bar and z. Now what is the function? Boolean function of that particular logical expression. So this is equal to x bar y plus x bar y bar plus y bar and z. So this is the most simplified form of this Boolean function. Okay. Next one is if I consider another example. Suppose another example. So for 3 variable, if I consider, so this is x and y and z. This is 0 0 0 1 1 1 and 1 0, and this is 0 and 1. For example, so this is 1, this is 1, and this is 1, and this is 1. So what will be the output? Yes. Now if I fold this table, so what will be happen? So this consecutive one and this consecutive one will be in an adjacent cell. So that is why, so it is possible to prepare a big group. So within the big group, so what will be the output? This output here. So that means output means the Boolean expression output. So if I consider this big group, this x is already changed because this value is 0, this value is 1, x is already changed. Similarly, y is already changed because in that particular case y value is 1, in that particular case y value is 0. Only the z is unchanged. So what is the z? Z value is 0. So that is what? So for that particular cases, the output is z. Okay. Next one is if I consider another example, suppose for 3 variables. If I consider this, suppose this is 1, 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 and suppose this is 1. So what is the output? Now we can make a group from this to this. We have already discussed in the previous one. If I fold this one, so this adjacent and this adjacent will be this one and this one will be the adjacent one. So this is the first group G1, and another group is, suppose if I consider this 2 1 and consider this 2 1, so this is 2. And what is the output? This output is G1 plus G2. And what is G1? G1 means only the unchanged variable is the particular cases Z1. So G1 in a group G1, so this will be Z1. And in a group G2, so what is the expression? X is already changed from 0 to 1, and Z is already changed from 0 to 1, and only the unchanged is 0 to 0. So that is why 1. So total this output is y bar plus z. This is the Boolean expression for that particular. Okay. So this is basically the 3 variables. Next one is, if I consider the 4 variables, so what will happen? So 4 variable means 2 to the power 4. 2 to the power 4 means 16th combination is there. Suppose input is A, B, C and D, and this is the corresponding output here. And now if I consider this, suppose this is 0, 0, 0, this is 0, 0, 0, 1, 0, 0, 1, 0, this is 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. Next one is 1, 0, 0, 0. Next one is 1, 0, 0, 1. Next one is 1, 0, 1, 0. Next one is 1, 0, 1, 1. Next one is 1, 1, 0, 0. Next one is 1, 1, 0, 1. Next one is 1, 1, 0. And last this is 1, 1, 1. So this is 16 possible combination, and this is the mean term version of 0. This is 1, this is 2, and up to this one is 10, 15. Okay. Now, if I consider the 4 variable KMF, so what will happen? 16 cell will be there. 16 cell will be there. This is A, B, C, and D. This is 0, 0, 0, 1, 1, 1, 1, 0. This is 0, 0, 0, 1, 1, 1, and 1, 0. Okay. This is the mean term position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The position will be like this. Now, if I consider, suppose this is the possible combination and this output is, for example, this position is 1 and this position is 1, and suppose this position is 1 and suppose this position is 1. So what is the meaning of that? M0 position is 1. This is M0. M1, M2, M3 position is 1. And M4, M5, M6, M7 is suppose is 1 and M15 is suppose 1. So just M0 position is 1. And next one is M3, M0, M1, M2 and M3 position is 1. And M4, M5, M6 and M7 position is 1. And M8, M9, M10, M11, M12, M13, M14, M15 is value is 1. Now for that particular cases, so we can prepare a group. This is the group 1 and this is the another group. This is the group 2 and this one is fully independent. So there is no group is there. So that is why F is equal to, now if I consider the group 1, only the unchanged variable is changing variable is in that particular case b, because b in that particular cell b was 0 and in that particular case b was is 1. Unchanged variable is b and so change variable is b. Rest of the unchanged variable. So that is why. So this is a bar, a bar, a bar, and this is C and D. So this is for the group 1, and for group 2, so this is the group 2, only unchanged variable is changing variable is A from 0 to 1, the rest of the unchanged. So this is B, C, and D. So this is the Boolean function of this particular cases. Okay. Next is I'll give another example. Suppose this is the 4 variable K map. This is the 4 variable K map. How many cell will be there? 4 variable K map cell will be 16. This is A, B, and C and D. Now, for example, suppose Boolean function of this. So this is equal to suppose mean term of 0, 1, 2, 3, 4, 12, 13, 14, and 15. So what will be happen? So this is 1, this will be 1, this will be 1, this will be 1, 0, 1, 2, 3, and 4, 5, 6, 7, 8, 9, 8, 9, 10, 11, 13, 14, 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12, 13, 14, and so basically, so this is the example of 4 variable. Now, so this is the first group, and this group consists the 4 element. This is group 1, and this is another group. This is the group 2. This is group 2, and we prepared the another group. So it will be this is what will happen in a group 1. So what is the value? This value is this is 0, 0, 0, 1, 1, 1, and 1, 0. This is 0, 0, 0, 1, 1, 1, and 1, 0. The only unchanged variable is AB. What is the value of AB? 0. So that is why in the group 1, this is A bar, and in a group 2, the only unchanged variable is AB. So this is 1. So that means this will be AB. And now if I consider the group 3 is the possible combination is, so that means CD is unchanged and B is unchanged. B is unchanged is from 1, and group 3 B is unchanged from 1 to 1, so that is why this is B, and another unchanged is C bar. And so what is the Boolean function? Boolean function is equal to A bar, B bar plus AB plus B, C bar, and so this is the Boolean function of this. Now for another example, if I put the another values, suppose in this case it is 1, so what will be happen? Okay, so that times, so it will be prepared. So this is the first group, no issues is there, and this will be the second group, and third group will be these two things. So that times it will be some changes. Okay, because if I fold this one and this one and this one and this one will be adjacent. So that is why it prepared a big group. For that particular cases, so what will be the Boolean function? What is the expression? So expression is G1 is as it is, and G2 is also as it is, and G3 will be little bit changed. So what will be happen G3? So if I fold this one, so only the unchanged variable is B, and here unchanged variable is D. So B and D1. Why it is D1? Because unchanged is from 0 to 0, and here B is unchanged from 1 to 1. So that is why this is. Okay, now if I add the 1 here. Again, if I add here and here, so what will be happen? So this will be, I will discuss in detail. Look, suppose this is the another Boolean function for variable. So this is A, B, C, and D. This is 0, 0, 0, 1, 1, 1, and 1, 0. This is 0, 0, 0, 1, 1, 1, and 1, 0. Suppose this is 1, 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 this is 1. So what is the output? What will be the output? Yes, if I fold this one, and this fold, and this ones, and this one will be adjacent. So we can make a group these two, because if I fold this one, this conjugative one will be in a adjacent group. So that is why F is equal to what is the one group? Suppose G1. So which one is unchanged? So CD is always changing. So first of all 0, 0, 0, 1, 1, 0, 1, CD is already changed. Only the unchanged variable is there, B. So in that particular case, B was 0, A was 0, and 1. This is also changed, only B. So that is why this will be B. Now, so many possible combinations is there. So our motivation is, so we prepared a big group, and we will try to reduce the number of group. So then the K-map will be more simplified. Now K-map is more applicable for up to 4 variable and 5 variable, 6 variable. So this is the more complicated, and this is not easy to understand. So that is why today's topic. So we will discuss only up to